Today we will discuss about physics, its formulas, constant terms and values. Physics is a branch of science which deals with the study of matter, energy, force and motion and the way they relate to each other. Or a branch of science that studies how nature behaves. In the next content we will discuss some of physics topics. Bear with us. Our first topic is measurement. The process of determining the amount, quantity, degree, or capacity by comparison with an accepted standard. Precision. A measure of the consistency or repeatability of measurements. Accuracy. The degree of exactness of a measurement compared to the expected value, or the most probable value of the variable being measured. System of measurement. English, used in the United States, in some European and African countries, example, pound and foot. Metric, used by most of the rest of the industrialized countries, example, meter and kilogram. SI system. An international agreement set up a system of units called the International System. SI is based and derived from the metric system. The SI units of measurements. Length is in meters, mass is in kilogram, time is in seconds, temperature is in Kelvin, electric current is in ampere, luminous intensity is in candela, number of particles is in mole. Here are some SI prefixes and its equivalent symbol and exponential notations. Exa, peta, tetra, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, femto, atto. Vector quantity is a physical quantity that have specified magnitude and direction. Examples are acceleration, velocity, displacement, force and momentum. Scalar quantity is a physical quantity which has magnitude only. Examples are mass, speed, distance, temperature and volume. Here is the addition of vectors, where C is the sum, A and B are vectors, vectors to the right and up are positive, while to the left and down are negative. Product of the vectors, where theta is the angle between them. Here is the vector components. Also how to compute the resultant R of two or more vectors, V, either in parallel vectors, horizontal or vertical, or perpendicular vectors. Next up topic is work. Work, defined as the product of the force and displacement in the direction of the force, or the product of the force applied to an object and the displacement through which the force acts on an object. It is a vector quantity. Commonly the unit of work is joule. Work equals F multiplied by D, or F multiplied by D cos theta, where F is force in Newton, D is displacement in meters, theta is the angle in degrees. Energy. Defined as the capacity of doing work, commonly the unit of energy is joule. Potential energy. Energy possessed by an object by virtue of its position or configuration, or it is the energy by virtue of its position relative to a certain reference surface. P equals W, H equals m, G, H, where W is work, H is height, m is mass and g is acceleration due to gravity. 9.81. Kinetic energy. Energy possessed by an object because of its motion, or amount of energy possessed by a moving object. K, E, equals 1/2, m, v squared, where m is mass and v is velocity. Rotational kinetic energy. K, E, equals 1/2, I, omega squared, where I is rotational inertia and omega is angular velocity. Law of conservation of energy. Energy can never be created nor destroyed. It can only be converted from one form to another. Potential energy can be converted to kinetic energy and vice versa, without any loss of energy. Power. Time rate of doing work or rate at which energy is expended, common unit of power is in watts, can also be expressed in horsepower. 1 H equals 746 watts. Or, J per S. Or, Newton, meter per S. Equals W over T or, F multiplied by S over T. Where, W is work, F is force, S is distance and T is the time. Laws of motion. On 1687, Sir Isaac Newton published a book called Principia. In this publication he sets out the law of universal gravitation, an extension of Kepler's laws of planetary motion and also the different properties of motion, now called as the Newton's laws of motion. Newton's first law. The law of inertia, every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Newton's second law. The law of acceleration, acceleration of an object depends on the mass of the object and the amount of force applied. Acceleration is inversely proportional to the mass, the heavier the object the less its acceleration. Force equals mass times acceleration. For constant mass and varying acceleration, F is equal to m multiplied by velocity 1 minus velocity 0 over time 1 minus time 0. Newton's third law. The law of action-reaction. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. Force always acts in pairs. Gravitational force is a force of attraction between two bodies and it is dependent on the mass. The more massive the body is, the larger its attractive or pulling capabilities. Example: the Earth has more mass than the molecules in the atmosphere, that is why the Earth is pulling the molecules of the atmosphere towards its surface. The Sun is more massive than the planets in the solar system, hence the Sun keeps the planets on its orbits. Newton's law of universal gravitation. All objects attract each other with a force of gravitational attraction. This force of gravitational attraction is directly dependent upon the masses of both objects and inversely proportional to the square of the distance that separates their centers. F is equal to g multiplied by m1 and m2 over d squared, where g is called the universal gravitational constant. Friction is a force that tends to oppose motion or impending motion. Friction will never create motion, it will just resist motion. Static friction. Friction that is acting between surfaces at rest. Commonly it is greater than the other type of friction. F max equals μs multiplied by n, where n is the normal force and μs is the coefficient of static friction. Kinetic friction. Friction that is acting between surfaces that are in relative motion. Also called as sliding friction. Fk is μk times n, where n is the normal force and μk is the coefficient of kinetic friction. Below are some common coefficient of friction. Momentum is the product of the object's mass and its velocity, or the amount of motion that an object has. An object that is stationary has no momentum. It is a vector quantity. P is equal to mass times velocity. Impulse. A vector quantity that describes the effect of a net force acting on an object. It is a function of force and time. It is equivalent to change in momentum. J equals force times change in time. J equals constant mass multiplied by change in velocity. J equals mass times velocity final, a velocity initial. Law of conservation of linear momentum. If the net external force acting on a system of bodies is zero, then the momentum of the system remains constant. If two objects will collide, the total momentum of the two before and after collision should not change. Elastic collision is a collision in which there is no loss in kinetic energy in the system as a result of the collision. The momentum remains constant as well as the magnitude, but the direction is changing. An elastic collision, a collision in which there is a loss of kinetic energy, total momentum of the two bodies remains the same, but some of the initial kinetic energy is transformed into heat, light or sound energy. Coefficient of restitution is the negative ratio of the relative velocity between the objects after collision to the relative velocity between the objects before collision. E is equal to negative V, A, 2 minus V, B, 2 over V, A, 1 minus V, B, 1. Where V, A, 1 is initial velocity of object 1, V, A, 2 is final velocity of object 2, V, B, 1 is initial velocity of object 1 and V, B, 2 is final velocity of object 2. If V equals 0, then it is a perfectly inelastic collision. If 0, less than E, less than 1, then it is a real-world inelastic collision. Silence msk equals 1060, greater than. If V equals 1, then it is a perfectly elastic collision. Another way to get the coefficient of restitution in terms of height, initial height and bounce height. E is square root of height bounce over height initial. Simple machines can change the amount of force you must apply to an object, and the distance over which you apply the force. Make work easier, but they do not decrease the amount of work you have to do. Actual mechanical advantage. It is the ratio of the output force exerted by the machine on the load to the input force exerted by the operator on the machine. Or mechanical advantage of a real machine with all of the inefficiencies. AMA is output force over input force. Ideal mechanical advantage. It is the ratio of the distance through which the input force acts to the distance through which the output force acts. Represents the change in input force that would be achieved by the machine if there were no friction to overcome. Or the mechanical advantage of a machine with no inefficiencies. IMA equals input distance over output distance. Efficiency. Ratio of its output work to its input work. Eta equals output work over input work, or AMA over IMA. Vibratory motion. Type of motion that regularly repeats, meaning the object returns to its initial position after some time. Simple harmonic motion is a type of vibratory motion in which the acceleration is proportional to the displacement and always directed toward the equilibrium position. T is 2 pi multiplied by square root of m over k, or 1 over 2 pi multiplied by square root of k over m, where T is in seconds, m is the mass and k is force or spring constant. Simple pendulum. System that follows simple harmonic motion, consists of a concentrated bob, with mass and attached to a string with length and negligible mass. T is 2 pi multiplied by square root of L over G, where T is in seconds, L is the length of the string, in meters, and G is acceleration due to gravity, 9.81. Angular frequency of the pendulum, omega equals 2 pi f multiplied by square root of G over L, where f is frequency of oscillation. Torsional pendulum. This type of pendulum twists back and forth with respect to its equilibrium position. T is 2 pi multiplied by square root of I over kappa, where T is in seconds, I is the moment of inertia and kappa is torsional constant. Hooke's law states that the strain of the material is proportional to the applied stress within the elastic limit of that material. F is negative K and X, where F is external force, K spring constant, and X is length of extension or compression. Fluids. Anything that flow, includes liquids and gases, divided into two types, the ideal and the real fluids. Ideal fluids. No viscosity, incompressible, have uniform velocity distribution when flowing, no friction between moving layers of fluids, no eddy currents, no turbulence. Real fluids. Viscosity, compressible, non-uniform velocity distribution, experience friction between moving layers of fluids, turbulent in flow. Real fluids are of two, Newtonian and non-Newtonian. Newtonian fluids have constant or uniform viscosity, non-Newtonian are those viscosity will vary with velocity. Density is mass per unit volume. The higher the value of the density of a certain fluid, the more compact the particles are packed within the substance. Density can be kilogram per cubic meter. Density equals to mass over volume. Relative density or specific gravity is the ratio of the density to that of water at 4A degrees C. At 4A degrees C, the water has its highest density value. Sg is density of a liquid over density of water. Below are the relative density or specific gravity of common substances. Specific volume is the volume occupied by a unit mass of fluid. It is the reciprocal of density. Specific volume is on over density of volume over mass. Specific weight is the weight of the fluid per unit volume. The product of the density and the acceleration due to gravity. Unit can be Newton per meter squared. Viscosity is the measure of a fluid's resistance to flow when acted upon by an external force. Fluid with high value of viscosity will flow slower, compared to a fluid that has lower value. Surface tension. The property of the surface of a liquid that allows it to resist an external force, due to the cohesive nature of its molecules. The tension of the surface film of a liquid caused by the attraction of the particles in the surface layer by the bulk of the liquid, which tends to minimize surface area. Cohesion refers to the attraction of molecules for other molecules of the same kind. Responsible for surface tension, a phenomenon that results in the tendency of a liquid surface to resist rupture when placed under tension or stress. Adhesion is the attraction of molecules of one kind for molecules of a different kind. Enables water to climb upwards through thin glass tubes, when called capillary tubes, placed in a beaker of water. Capillarity is a phenomenon in which liquid spontaneously rises or falls in a narrow space such as a thin tube or in the voids of a porous material. When a glass tube opened at both ends, dipped into a water, the liquid rises in the tube above the general level of the outside liquid. If a glass tube dipped in liquid mercury, the level of liquid inside the tube is lower than the outside. Bulk modulus, measure of how resistant to compression the substance is, the ratio between pressure increase and the resulting decrease in a material's volume. Compressibility, measure of the relative volume change of a solid or a fluid in response to a pressure change. The fractional change in the volume of a fluid per unit change in pressure at constant temperature process. Pressure is defined as the perpendicular force per unit area that a fluid exerts on any surface with which comes in contact. Manometer, an instrument used to measure difference in pressure. Barometer, an instrument used to measure atmospheric pressure. P is force over area. Hydrostatic pressure, pressure due to a column of fluid. P is density multiplied by H and G, where ρ is the mass density of fluid, H is the height and G is the acceleration due to gravity. Pressure variation with depth in a static fluid. It is equal to P1 plus ρ multiplied by D and G, where P2 is pressure at a depth D below P1. Pressure at a depth D below the surface of a liquid open to the atmosphere. P equals F A T M plus ρ multiplied by D and G, where PATM is the atmospheric pressure, 1 atmosphere, D is the depth, ρ is the mass density of fluid and G is the acceleration due to gravity. Pressure variation with depth in a static fluid, P gauge, is the amount by which the absolute pressure exceeds the atmospheric pressure. P gauge equals PABS minus PATM, where PABS is the absolute pressure, PATM is the atmospheric pressure. Pascal's principle. The pressure applied to a confined fluid increases the pressure throughout by the same amount. P1 is equal to P2. Force 1 over area 1 is equal to force 2 over area 2.